research details response of sagebrush to 2017 solar eclipse. The total solar eclipses swath across Wyoming and the United States in August 2017 provided an opportunity for scientists to study a variety of celestial and earthly phenomena, from learning more about the sun's corona to the behavior of animals and plants. University of Wyoming botany and hydrology doctoral student Daniel Beverly used the eclipse to examine the impact of the moon's shadow on an iconic plant species of Wyoming and the Intermountain West, big sagebrush. He found that the short period of darkness caused a significant reduction in photosynthesis and transpiration in the desert shrub, but not quite to the levels of nighttime. Additionally, the circadian rhythm, the response to the internal clock common to nearly all organisms including humans, was interrupted by the sudden changes in sunlight beyond typical cloud cover. The reduced temperature and lack of sunshine shocked the circadian clock of big sagebrush, triggering a response far beyond what happens when clouds block sunlight, says Beverly, whose research appears today, Thursday, in the journal Scientific Reports. However, the duration of eclipse totality was not sufficient to bring the plants completely to their nighttime state. Scientists have extensively studied the response of animals to total solar eclipses. Those findings have been mixed, with birds, bees and spiders behaving just as they do at dusk, while no behavioral change was observed in animals such as dairy cattle and captive chimpanzees. On the other hand, very little is known about plant responses to eclipses, either on the small scale or across broad ecosystems. Beverly's study, which involved fellow UW scientists in the Department of Botany, the program in Ecology and the Wyoming Geographic Information Science Center, offers some of the most detailed information about individual plant response and potential broad ecosystem impacts ever reported. Beverly's fieldwork took place at a site about 50 miles southeast of Yellowstone National Park, which was within the eclipse's path of totality August 21, 2017. That area is dominated by mountain big sagebrush. The site experienced 2 minutes, 18 seconds of eclipse totality, with the total duration of partial and total solar eclipse reaching 2 hours, 45 minutes, 36 seconds. Devices deployed during the study included a micrometeorological tower to record the sun's radiation and changes in temperature, an infrared gas analyzer to measure photosynthesis, and fluorometers to measure leaf response to changing light conditions. During the short duration of near darkness, they found significant reductions in transpiration, evaporation of water from sagebrush leaves, as well as photosynthesis, the transformation of light energy into chemical energy that converts carbon dioxide and water into sugar and oxygen. In addition to documenting the response of specific sagebrush plants to the eclipse, Beverly and his colleagues used those results to estimate the eclipse's impact on sagebrush-dominated areas within the path of totality. They calculated a 14% reduction of carbon being converted in western big sagebrush ecosystems that one day. Despite its relatively short duration, the eclipse caused a significant reduction in estimated daily carbon uptake for August 21, 2017, in big sagebrush ecosystems, Beverly says. This information gives us a more comprehensive understanding of plant physiological responses to sudden changes in light, temperature and humidity that the internal clock fails to predict. Importance of climate on spruce beetle flight. If the climate continues warming as predicted, spruce beetle outbreaks in the Rocky Mountains could become more frequent, a new multi-year study led by Colorado State University finds. While insect disturbances naturally cycle through forests, the current spruce beetle epidemic affecting Colorado Engelmann spruce forests has been one of the largest on record. The Colorado State Forest Service estimates that since 1996, over 40% of the state's high-elevation forests, encompassing an area larger than Delaware and Rhode Island combined, have already been affected by this latest cycle. According to the research team, this has resulted in a widespread die-off of trees valued for their contributions to clean water, recreation and wood products. The study, recently published in Environmental Entomology, provides new clues about spruce beetle behavior. Study co-authors Seth Davis, assistant professor in CSU's Forest and Rangeland Stewardship Department, and Isaac Dell, a graduate student at Montana State University, combined new beetle population and environmental data with climate projection models to see what could be in store in the future. Unfortunately, what we found suggests there is no best-case scenario, said Davis, a specialist in plant and insect interactions. Even if the climate increases by just 1 degree Celsius, we can expect spruce beetles to reproduce at higher rates than we've seen, with more time to invade trees. Their results indicate slightly warmer conditions could contribute to longer flight periods and more eruptive beetle populations, due to larger populations of fertile females. This combination could equate to more intense insect pressure on spruce forests. Temperature plays a critical role in this species' life cycle by affecting the insect's development, dispersal and flight patterns. At field sites that span the length of Colorado, Dell collected hourly temperature data along with more than 70,000 insects across the 2017 and 2018 growing seasons. With corresponding winter temperature data from the PRISM Climate Group at Oregon State University, some patterns emerged. It became apparent that beetles in 2018 were larger in size, after a warmer and drier winter than in the previous year, and that females were also more numerous, said Dell, who recently graduated from CSU with a master's degree in forest sciences. By adding 1 degree Celsius to the daily temperature data set, climate projections showed a likely increase of 200 growing degree days, which are used to predict plant and animal development, at these locations. This projection is based on the assumption that new global greenhouse gas production would be eliminated by 2020. According to the researchers, this could extend the beetle's potential flight period from a few weeks to multiple months. The study found that the insect's flights would also become more varied, making coordinated beetle attacks harder to predict. To monitor these populations and subsequent impacts on Engelmann spruce trees, Dell said management efforts need to consider this expanded time period. For monitoring efforts, the best course of action for people is to place traps out earlier in the season, added Dell. We also recommend removing infested trees and traps in August, at the end of the beetle flight period. Davis said that while this scenario isn't good news, he remains an optimist. By his estimates and through personal observation, up to 30% of beetle-infested, high-elevation forests have survived. It's not always as bad as it looks when you're driving by, he said. These interactions have been happening for thousands of years, and life, whether it's a beetle, a tree or a forest, seems to find a way.